Hello everyone and welcome to this next session of the CCNA X 2.0 online training. Okay. Now today's agenda is just a continuation of building a simple network which we left off in the previous session. Okay, so we are going to continue with configuring the switch or the command line interface of the switch. Okay, so that's what we are going to continue. But before we do that, let me do a quick revision of whatever we covered until now. Okay, in fact, yesterday most of the topics that we covered yesterday was about Ethernet. Okay, we talked about a bit about collision domains, the advantage of switches or the features of switches, and then most importantly we talked about configurations. Okay, configurations as in we talked about the two major types of configuration that is available on the device. One is the running config which resides in the RAM, and then we have the startup config which is stored in the NVRAM. Okay, so these are the two major things that we looked at. Apart from that, we also talked about things such as the boot up process of the device. Okay, so when we talk about the boot up process of any Cisco device, the first thing that it does is it runs the power on self test, wherein it checks each and every individual hardware component of the device. The second step that it follows is it tries to find or search and load the iOS operating system, okay, of the device. So the iOS operating system by default is located in the flash, so that is what it's going to search for. So the moment it finds the iOS file, it loads the content of the iOS into the RAM, and then the third step that it does is it searches for the configuration in the NVRAM, and then it loads that configuration into the RAM. Okay, so with regards to that, I also showed you or covered certain commands like dir nvram colon. Okay, we also covered dir flash colon, by which we can see the contents of the flash and we can also see the contents of the NVRAM. Okay, we also covered some copy commands like copy run start or copy running config space startup config. That was the command to save the configuration. An alternative command that I taught you yesterday to save the configuration was write memory. Okay, apart from that, I also showed you how to, or I also gave you the command of how to take a backup of the configuration into TFTP by typing in copy startup config space TFTP, or if I want to restore a configuration from the TFTP, I can type copy TFTP startup config. Okay, so there were different types of copy commands that I showed you. Apart from that, I also illustrated and talked about how to erase the configuration of a device. Okay, so to erase the configuration, the command that is used is erase startup config, and then after that you have to reload. Okay, so when the device reboots, that's when the device will start blank. Okay, so these are the things that we talked about. Apart from that, to work on the command line, we also talked about certain shortcuts like Control P, that is nothing but the previous command is what it can show you. Control N, that will show you the next command, or you can also make use of up arrow and the down arrow to scroll through all the previous commands or the next command that you have executed. You also have a command by which you can see the list of all the commands that you've executed, that is show history. Okay, and then you can set the history size by typing in terminal history size, and you'd have to define the number of commands that it has to remember. Like yesterday I gave you an example wherein I set the terminal size to terminal history size 100. What that means is it can recall 100 commands that you've executed before. Okay, so that's the kind of commands, or that's the thing that we talked about with regards to the switch. So overall, we had a brief introduction towards the command line interface that is available through the Cisco IOS. Okay, so that's what we talked about yesterday. Apart from that, okay, today what we are going to do is continue with that, and today we are also going to talk about some improved or advanced features that are available in the command line interface. Okay, so typically when we talk about the command line interface, one of the commands that we talked about yesterday was show running config, and we also talked about show startup config. These two commands allow us to view the configuration of a device. Okay, now when I talk about the configuration of a device, it's naturally going to be a long one. Okay, it's going to be a big configuration. Okay, like just let me show you a demo for that. if I go into packet tracer right now, that's my switch. Okay, and I'll go into the command line interface of the switch. Okay, so that's what I get. So I'll just press enter, and now it's a blank switch. So I'll just type enable. Okay, that will take me into the privileged exec mode. Okay, once I do that, I'll type show running config. Okay, so when I do that, as you notice, it's a long list of commands, and then the entire configuration is spread out into pages, like wherein right at the end of the page it shows more. Okay, so out here, if I press enter, it's going to take me line by line, but if I press spacebar, it's going to take me page by page. Do you see that? Okay, so you can see the entire configuration line by line by pressing enter or return, or you can see page by page of the configuration by pressing spacebar. Okay, so that's the kind of a thing that you can do. Okay, but saying that, okay, what if I want to only see a specific part of the configuration? I do not want to see it page by page, or I do not want to see the entire config. Like when I type show running config, and that's the output that it gives me, but this was shown to me in a page by page fashion, or I could see it in a line by line fashion. But let's say I want to only see a part of the configuration. I do not want to see the entire configuration. That's where I can make use of some filter commands. Okay, now let me show you how to make use of these filter commands. Okay, so I'll run the same command by pressing the up arrow, but I won't press enter. Okay, so show running config is what I had executed previously. So I'll type show running config, and then what I'm supposed to do is I'm supposed to press pipe. Okay, now where do I find pipe? Okay, typically if you want to see this pipe command, you typically find this pipe command somewhere around the backspace key on your keyboard. Okay, so if you look at your keyboard, you should find the pipe key somewhere around the backspace that is available on your keyboard. Okay, now in my case, on my keyboard, the pipe command is available below the backspace. So if I press that button using the shift command, that's when I get the pipe. Okay, so you'll have to look into your computer and find out where the pipe key is. But then remember, okay, it is more or less closer to the backspace. Okay, remember this is not I. Okay, this is not I, capital I. Okay, it is pipe. So shift and that button is what I'm pressing. So that's when I get this pipe. Okay, after pressing this pipe command, when I put question mark, see, as you notice, it's giving me an error or unrecognized command. That's because, okay, when I talk about a switch, okay, most of the times, or since I'm running the switch on a packet tracer, it may not support the filter commands. But then what are the options available to me? Okay, whenever I talk about the filter command, I have options like include, begin, and then I have section. Okay, so let me elaborate on those. Let's first start off with include. Okay, so what I'm going to do is, after the pipe, I'm going to type include hostname. So what is that going to do? It's going to show me all the lines in the configuration where it finds hostname. Okay, let me just do that and show it to you. So typically I would type show running config pipe include. Okay, that's what I need to type, include, and then hostname. Okay, so when I run this command, what it's going to basically do is it's going to search through the entire configuration, and it's just going to include the line which has the host name written on it. Okay, so let me try executing this command in the packet tracer. So the bottom line is, in the packet tracer, it is not supporting the pipe command. But if it was a live device, okay, if it was an actual switch, I would have found that after the pipe, if I include and then hostname, I would have found this line. It would have shown me this line. You understand? Only this line. It wouldn't have shown me anything else, but it would have shown me a single line out of the configuration, that is hostname and switch. Okay, so that's the purpose of the include command. Another option that is available to you apart from include is begin. Okay, so I can also type show running config space pipe space begin and then hostname. When I do that, okay, what it's going to do is it's going to begin the entire configuration, or it's going to show me the configuration beginning from this line. Okay, because in this line we have hostname. So it's going to show me the configuration beginning from this line. Okay, so it's going to show me all this portion of the command. Okay, so that's the role of begin. Okay, so do you understand the difference between include and begin? Include will only show me the line where that command is located, whereas begin is going to show me the entire configuration starting from what I have specified. Like in this case, if I type begin hostname, it's going to begin the configuration starting from hostname. Okay, so that's what it's going to do. Clear about that? Okay, so have you understood the difference between these two? Okay. Now, the next portion or filtering command that is available is I have an option to say section. Okay. Now, the problem with begin is it will show me the configuration beginning from hostname, and include will only show me the line where hostname is located. Okay. But if I want to see an entire set of the configuration, like for example, if you see this part of the configuration which I am highlighting right now, it says line VTY 0 space 4 and then login. Now what is this command? What it does? Well, we'll discuss it about this particular command at a later part of this particular course. But then what this command really does is it allows me to configure telnet on the device. Okay, that is the purpose of this command. But I'll explain that to you more when we get to that portion of the topic. But right now, you know, I want to see this entire section. Okay, but if I type show running config include line, what it's going to do? It's going to just include this line. That's it. It's not going to show me the login command which is inside it. Okay, so it's going to be stuck out there. And if I type begin and then line, it's going to start the configuration and it's going to show me this entire stuff. But if I do not want to see this entire thing, I just want to see this section, let's say. Okay, let's say I just want to see this section, or I just want to see this section. So if I want to do such a thing, that's where I would type in instead of section, that's where I would type after the pipe, I'll type section, and then I'll type, let me just type it in again. So after the pipe, I'll type section and then line VTY. So what's that going to do? It's going to show me this entire section. In fact, since I have typed section line VTY, it's going to show me this line VTY plus this line VTY. Do you understand that? Okay, so it's only going to show me that section of the configuration which is related to line VTY. Okay, so it is a very good command that is available, but unfortunately in the packet tracer I am not able to demonstrate this filtering command or filtering command line option. Okay, that are available. But I hope you understood the difference between pipe and include, pipe and begin, and pipe and section. Okay, so are you clear about all these command line options? Okay, so let's go ahead. Okay, so that is an enhancement with regards to working on the command line. Okay, so that was this section, okay, which we completed, wherein it talked about the privilege mode and the user mode. Then we also talked about the various show commands that are available to view the configuration commands, how to take a backup to a TFTP server, how to restore the backup from the TFTP server, how to save the config, how to remove the config or erase the config, okay, the reload command. That's what we talked about in this section. Now let's get on to the next section, which is again going to be a continuation of working on the command line. So when it comes to that, now what we are going to focus upon is starting a switch. Okay, so when I get to work on a switch and when I power on a switch, okay, what's going to happen? That's what we are going to talk about now. Okay, so for understanding this section, what I'm going to do is I'll just close this, and what I'll first do is get on into the switch. Okay, and I'll come in here. Okay, and when you look at this particular switch, okay, I actually need to have a power button. But when I talk about a switch as a device, the switch does not have a power button. That's the problem with it. Okay, when I talk about a router as a device, the router has an on-off button on it by which we can power off or power on the device. But when it comes to a switch, the switch does not have a power on and a power off. Okay, the only option that you have is you just plug in the cable, power cable on it, and it comes on. Okay, so there is no power on or power off switch on the switch. That's the reason I will not be able to show you power on and power off. Okay, but then let me show you what happens when the switch is turned off and turned on. Okay, so let me just show you that part. So for demonstrating that to you, what I'm going to do is I'm going to type reload. Okay, I'm going to reboot the switch, and when I type in reload for that to reboot the switch, it's asking me proceed with reload. It's asking me for confirmation. So I'll just press enter here. When I do that, that's the kind of a screen that comes up when the switch is rebooting or when you power on the switch. Okay, so as you notice, it has detected the iOS and it's booting it up, and immediately you notice it has shown you all the ports that this switch has, and plus it's also telling you what switch are we working upon. Okay, it's saying that it's C2960. C2960 means that is Cisco 2960. Okay, so it is a Cisco switch working on the platform 2960. That's the model number for this particular switch. Okay, and as far as the iOS version that is running, it's saying SW version. SW version is nothing but software version. So the iOS version for this particular switch is 12.2. Okay, so it's running 12.2 version of the iOS. Okay, now once it completely boots up, that's the kind of a message that it comes up with. Okay, yeah, the reload command is basically used to reboot the switch. Do you get that now? Okay, so you have to make use of the reload command to reboot the switch. There you go. Okay, so that's what I ran, reload. You understand? Okay. Okay, so that's what I get once it boots up. So it's asking me press return to get started. Return means enter. So let me press enter, and there you go. I get into the user exec mode. Okay, so typically this is what happens. But now let's go through the topic slide, okay, and understand what happens when I start a switch. Okay, so when it comes to the switch installation, okay, one of the main things that you need to take care of. Okay, now this is not just related to the switch, any device installation. When I talk about it, the first thing before installing the device, you have to verify the power and the cooling requirements for the device. Okay, now when we talk about Cisco routers or any kind of a networking device, be it a Cisco router or any third-party device like a third-party router or a third-party switch or a Cisco switch, okay, you have to be very careful, or you have to understand that the devices, if they are on for a long period of time, okay, they get heated up. Heated up as in they are going to generate a lot of heat because they are powerful systems, right? So that's the reason it's very important for you to take care of the cooling requirements as well. Okay, and you have to provide them with the appropriate power supply as well. So before installing a switch, you have to verify whether you have the appropriate power supply outlets, plus you have taken care of the cooling requirements, like whether you put up or set up an air conditioner, or whether you put up appropriate ventilation so that the hot air is thrown out and the air is circulated in the area where you are going to put up the switch. Okay, now when it comes to physically installing the switch, the first thing that you have to look out for is, okay, since the switches or the routers typically they are put up into a rack, so you need to have the appropriate rack mount if you are going to put up the device inside a rack. Okay, if you are going to place the switch on a wall bracket, that is like you are going to place a stand on the wall, and then if you are going to place the switch on top of that stand, then in that case you need to have a wall mount. If you are going to place the switch on a table or in a shelf, then in that case you need to have a table or a shelf mount. So you have to see to it that the switch can be placed securely. The next thing that you're supposed to look at is to verify whether you have the appropriate network cabling. Now at this point of time, we have not really discussed about network cabling, or we have not understood the various kinds of network cables that are available. We'll talk about it soon enough. But then, okay, that is another aspect which you need to look out for, whether the network cabling is thought about properly. Then what you need to do is you need to attach the power cable. Okay, the power cable plug has to be plugged into the switch, because when it comes to the switch, like I told you before, there is no power on or power off switch. You have to just take in the power cord and plug it in into the switch device. Okay, so that's when the switch is going to start off, and the moment the switch starts off, it's going to start off with a post, that is a power on self test, wherein it will check each and every hardware component, and then it's going to initiate the switch software. Switch software means the iOS software. Okay, so that's the kind of a thing that is going to happen when it comes to installation of the switch. Okay. Okay, so when it comes to the initial startup of the catalyst switch, okay, the moment you plug in the power cable into the switch is going to turn on. Okay, so what the switch is going to do is it will take the initial startup, or it will take the default configuration parameters, and it's going to boot up. Okay, that's what is going to happen, because by default a switch does not have any configuration, so it will have a blank configuration, and that's why it's going to boot up using default configs, and that's what you see even in a packet tracer switch. Okay, if you notice out there, it has come up with a default configuration wherein there is no host name. It's using the default host name of switch, and nothing is configured on this particular switch. Okay, so before you start the switch, verify that the cabling and the console connection has been put up properly. Okay, so as I told you before in my previous session, okay, when it comes to configuring the switch or the router, you have to connect the router or the switch via a console cable. Okay, so the console cable, when I talk about it, typically it is an RS-232 cable. Okay, now what do I mean by an RS-232 cable? An RS-232 cable would be typically like, at one end of the cable you'll find that it's like a serial port, and on the other end of the cable you'll find that it's like a network cable. I'll show you a diagram or a picture of the console cable as we go ahead, but that's the kind of a cable that you need to connect the console. Okay, so typically let me show you how to do that. Okay, so basically what I'm going to do is I'm just going to close it. Now that's my switch that we have. Okay, so I'll place a machine out here. So to place a machine under packet tracer, I'll go into the end devices section out here. If you can see my mouse pointer, I'll click on end devices. When I do that, there you go. It gives me the option of a desktop as well as a laptop. So let's say I choose a laptop, because nowadays most of the time you find that you have a laptop. Okay, now nowadays when you purchase a laptop, it does not have a COM port. Laptops nowadays do not have a COM port. Okay, so in that case the laptop definitely has a USB port. So typically the console cables have a USB to serial converter, and through that you can connect the console cable. Okay, so that's what you can have. So now in this case what we are supposed to do is, okay, we are supposed to then go into, okay, once you have placed the laptop and the switch, we are then supposed to click on connection. Okay, so as you see my mouse pointer, I clicked on connection. The moment I click on connection, out here there are various choices that are available to me. Like I have automatically choose connection type, I have console, I have copper straight through, I have copper crossover, I have fiber, I have phone. Okay, so there are a lot of different options available out here, but I'm going to choose console because I want to connect the console port of the switch into the machine. Okay, that's what I want to do. So I'll click on the console, click on the switch now. When I click on the switch, these are the ports that are available on the switch. So what I'm going to do is I'm going to click on the console port. That's where I'm going to plug in the console cable. And as you see, this blue line originating out of it, because the one end of the cable has been plugged in onto the switch, the other end has to be plugged in into the laptop. So when I click on the laptop now, it's giving me two options again, fast Ethernet and RS-232. So I'm going to click on RS-232. That's nothing but the serial which I was talking about. Okay, so that's the serial connection that we get. Okay, so once I get this kind of a serial connection, okay, now when I double click on the laptop, okay, so the laptop is indicating that it's a machine. Okay, so once I power on the machine, and when I click on desktop tab here, okay, now these are the various softwares that I can run on that machine. Okay, now typically when it comes to connecting to the device via console or to connect to the device via the serial connection, you have to click on a terminal application. Okay, so on this machine here we have a lot of different options like command prompt, web browser. Okay, then I have PC wireless, VPN. I have a lot of different options available here. But for connecting to the console via the serial, you have to click on the terminal software. Okay, so where do you get this terminal software? You have to double click on the PC or the laptop. Once you do that, you're supposed to get on into the desktop tab. When you click on the desktop tab, you have the terminal option here. You understand that? Okay. On an actual machine, okay, like if you have a physical machine or a real machine like a laptop, then in that case you're supposed to make use of a terminal software like PuTTY. Okay, PUTTY. PuTTY is one of them, or you can make use of Secure CRT. That's another option, or you can also make use of Hyperterminal. Okay, there are different software versions available. You can make use of any one of them that you want, but since I'm using Packet Tracer out here for this example, okay, I'm going to click on terminal. So the moment I click on this terminal software, these are the options that it's asking me. Bits per second is what I need to set. So the bits per second would be 9600. That's the default value. I'm not supposed to change that. Okay, so I'm supposed to keep it as 9600. Data bits have to be set to 8. Parity should be set to none. Stop bit should be set to 1, and flow control should be set to none. Okay, so in a different terminal emulator like PuTTY or Hyperterminal or Secure CRT, you would find a button out here which says Restore Default. So you are supposed to click on Restore Default. That's when it will automatically set all these parameters for you. Okay, so remember the bits per second should be 9600. Data bit should be 8. Parity should be none. Stop bit should be 1. Flow control should be none. Okay, so that's how it's supposed to be. Okay, so if you want, you can make a note of these parameters, but see to it that these parameters are the same. If you do not set these parameters, you may not see any text on the screen, or you may not get access to the command prompt or command line of the device. That's why it's very important that you keep these parameters as it is. Okay, so are you making a note of it? If yes, then just let me know. I'll wait for you. Otherwise, I'll proceed. Okay, so I'm just waiting for you to make a note of things. Okay, great. Okay, so now if I click on OK, there you go. That's the kind of terminal window that I get. Okay, now if I press enter here, there you go. I get the command line prompt of the switch. Okay, so the command line prompt of the switch which we were using earlier was by double clicking on the device directly. That's because I was using Packet Tracer. But in a real world device, if you have a real device with you, what you're supposed to do is connect the console cable into the device, and the other end of the console cable will come into your laptop or into your desktop onto your serial ports, and then there you set up those terminal options and you get the command line. Do you understand that? Okay, so that's the kind of a prompt that you would get, and now you can go ahead and configure the device. Do you understand that? Okay. So the console connection and all of these things have to be verified. Then you need to go ahead and attach the power cable to the switch power supply socket. That's when the switch will boot up, and then you can observe the boot sequence wherein the LEDs on the switch will glow. Okay, and then you would get the various input on the screen. Okay, like when I do reload on the switch, you see a lot of text coming up on the screen, right? That is what they're talking about with regards to software output text. Okay, so that's what typically happens when you power on the switch. Okay, so as such, when it comes to powering on, there is no button or there is no switch on the device. You have to just plug in the power cable and the switch will boot up. Okay, now typically these are the LEDs which it's talking about. On the upper portion of the port, you'll find a lot of LEDs talking about the port status itself. Then apart from that, on the left hand side, you find some LEDs out here like the system LED that gives you the system or the device status. Then you have the redundant power supply LED. Okay, redundant power supply LED, also called as RPS. Okay, redundant power supply is, okay, when I talk about high-end switches, they have an option of putting up multiple power supply. wherein even if one power supply module which is available on the switch goes bad, you can plug in the cable into the second power supply module, so that at no point in time the device is like completely down. Okay, you can at least power it on using the second power supply module. So in that, if that is the case, then this LED will come up. Then I have the port mode LEDs, okay, and then I have the mode button to set up the switch to either work in cut through or fragment free or store and forward, the different operational modes of the switch. Okay, so these are the different things or the different LEDs that are available out there which you can make use of. Okay. So when it comes to connecting to the device via the console port, okay, so on the side of the switch you find this port out here, okay, the one that is highlighted in blue, that is what is the console port. Okay, and this blue cable that you see below that is the console cable. Okay, so typically a console cable will have this kind of a port at one end, and on the other end it will have this kind of a port. So this port which you see out here, which I have highlighted, will go into the switch, and this port is supposed to typically go into the COM port of the computer. Now typically laptops, at a time one power supply will be used. That's right. Okay, when it comes to a device, at a time only one single power supply will be used. Okay, but for better redundancy or better fault tolerance, I can have multiple power supply modules put up, and then even if one of the power supply fails, I can switch over to the next one. Okay, that is the meaning of redundant power supply. Okay, yeah. So I was talking about the console port now. Okay, so the blue cable that you see out here is nothing but the console cable. Okay, so as you see, one end of the console cable looks like this, which goes into the switch port. Okay, that is this particular port out here. Okay, and then the other end of the cable will go into the laptop or the desktop. Okay, but the problem with laptops nowadays is they do not have a serial port or they do not have a COM port. Okay, so in that case, for laptops or typically for desktops which does not have a COM port, you need to make use of these kind of USB to serial port adapter. Okay, so that's the kind of adapter that you need to make use of. So in that case, this end of the cable will go over here, and this end of the cable will go into the laptop. You understand? So accordingly, it will detect that this cable is a COM port, and accordingly, it will allow you to connect via console. Understood about the connections out here? Okay, you didn't understand the last part. Okay, so the last portion that you see here is nothing but the USB to serial port adapter. Okay, this cable is typically used for laptops which do not have COM ports. Okay, this cable is nothing but the USB to serial port adapter. Okay, so that is for like if the laptop does not have a COM port, then this end of this cable will go into the USB port of the laptop, and the other end will go into this particular console port. Okay, that's where you will connect it, and accordingly then you can connect this laptop to the console port of the switch. You get that now? Yes, we would need both the wires. Okay, this is the console cable and this is the USB to serial connector for the machine. Okay, and you have to connect both of these, and one end will go into the USB port, basically will go into the USB port of the laptop, and the other end of the console cable will go into the console port of the device. Okay, so wherein both of these cables have to be plugged into each other because the laptop does not have a serial port, right? So that's where this cable will help you out with that. Okay, so once you are switching on or booting up the switch, you will notice, okay, that's the kind of an interface that you get, and that's what I showed you even in the packet tracer. Okay, so that's the kind of screen that you get wherein it's showing loading flash and then C2960. That's the software image that is loading up. Okay, so that's the kind of a thing that you would get. So typically you would have a console connection from the switch towards the computer, and through that console connection, that's the kind of output that you see when you're powering on the switch. Okay. Now, if the switch has a blank configuration, it's going to come up with this kind of a dialog box here, which says System Configuration Dialog. Okay, remember it is for an actual switch. Like if we had an actual switch here, okay, and if we power it on, and if it doesn't have any configuration, that's the kind of a dialog box which it will come up with. But in our case, since we are using packet tracer, we do not get this kind of a system configuration dialog, okay, because the packet tracer does not show it to you. But ideally, what is it used for? It is used for configuring the switch through a wizard. Okay, it will ask you certain questions. You fill up the questions with the appropriate answers, and your switch is configured. Okay, so you need not make use of any command line or anything of that sort out there. But then the point is, like we normally skip this setup dialog box. Okay, how do we do that? By choosing this option here. Go to the iOS command prompt without saving the config. Okay, that's what we are supposed to choose. So I'll choose 0, and then we can do that, or we can choose option number 2, which says save this configuration to NVRAM and exit. Okay, so that will save the configuration and exit. Okay, so there are various options that are available out here, so it depends on which one to use. But most of the times we'll choose 0, so that it skips the setup configuration dialog or system configuration dialog and directly comes up into the prompt. Okay. So once you get to the prompt that you get initially on the console port or the console connection is typically the user exec mode or the user mode prompt. On the user mode prompt, you are supposed to type enable. Okay, so we discussed about this in the previous session. So once we type enable out here, it will take you into the privilege exec mode. Okay, so when you first connect to the switch, it will be the user exec mode. In the user exec mode, you are supposed to type enable, and then it will take you into the privilege exec mode. Now, if you have configured some password on the device, then in that case, when you type enable, it will prompt you for a password by typing in enter password. Okay, so it will ask you for this question. But if there is no password configured, it will directly take you into the privilege exec mode. Do you understand that? Okay, so let me go back into the packet tracer. Okay, that's my command line console. Okay, so out here, when I type enable, what happens now? Here it's not asking me for a password because I have not set any password. Okay, but now once I've come into the privilege mode, if I want to get back into the user exec mode, okay, I have to type disable. Okay, so that will take me back into the user exec mode. Okay, again let me show it to you. When I type enable, it will take me back into the privilege mode, and then when I type disable, it will take me back into the user mode. Do you understand the two commands, enable and disable? Okay, but then at the same point of time, if I type enable and get into the privilege exit mode, I can also type exit. Okay, so even if I type exit, it's okay. But the problem with exit is, see, it totally takes me out of the user exec mode also, which means I have to again press enter, come back into the user exec mode. Okay, so that is that additional step which I need to perform. Okay, but if I type disable, it will directly take me into the user exec mode. Okay, so I need not press enter again to come back into the user exec mode. Do you understand that? Okay, so understood enable, disable, and exit. Okay, so going ahead, so these are the prompts that we get typically. Okay, so you'll have to be at the privilege exec mode for doing or carrying out any configurations of the device. Okay, so for getting into the privilege exec mode, the command for that is enable. Okay, now let's talk about some configuration commands of the switch. Okay, so from here on, or like I hope you're taking notes of things, because all the command line options is what we are going to cover right now. Okay, so it's very important for you to make notes so that you can refer back to those notes again, and you'll be able to retain all the commands better. Okay, so when it comes to configuring the switch, initially, okay, you would get into the privilege exec mode. Okay, so once you've gotten into the privilege exec mode, for carrying out particular configuration, you have to type configure terminal. Remember that. Okay. So for carrying out any configuration on the so on the switch, okay, in the privilege exec mode, you are supposed to type configure terminal. When you type configure terminal, look at the prompt now. The prompt now has changed to the name of the switch, and in round brackets it shows config. This mode is called as the global configuration mode. You understand? So for carrying out any configuration on the device, you have to first get into the global configuration mode. So what is the command to get into the global configuration mode? Okay, so the command for that is configure terminal. You understand that? Okay, so to get into the global configuration mode, the command is configure terminal. But to type in configure terminal, you have to be in the privilege exec mode first, and there you will type configure terminal. You understand? Okay, so you type configure terminal, and then you get into the global configuration mode. Okay. Apart from that, there are also a lot of different other modes available. One of them is interface configuration mode. So to get into the interface configuration mode, you have to first get into the global configuration mode and type in interface and the interface ID. Like in this case, if I talk about a switch has a lot of ports in it. Okay, a switch typically has a lot of ports in it. Like, let me just show that to you. If I go into packet tracer, and if I double click on the switch right now, and if I click on physical, there you go. These are all the ports that this switch has. Okay, so these are the individual ports, and each of these ports have an ID to it. These IDs are typically fast Ethernet 0/1, fast Ethernet 0/2, 0/3, and so on. Okay, now this switch, when I talk about it, okay, it has 24 fast Ethernet ports. Fast Ethernet means 100 Mbps. Okay, fast Ethernet means 100 Mbps. Mbps is megabits per second. Okay, whereas gigabit Ethernet means 1 gigabit per second. Okay, gigabit Ethernet means 1 Gbps, whereas fast Ethernet means 100 Mbps. Okay, so effectively there are 26 ports on the switch. 24 of them are 100 Mbps, and 2 of them are 1 Gbps each. Okay, so that's the kind of a number of ports that we have, and each of these ports have a particular identifier. Okay, so to get into that particular port, you have to type in interface and then the interface identifier, that is fast Ethernet 0/1 or fast Ethernet 0/2. When you do that, that's the kind of a prompt that you would see. Okay, so the prompt that you would get in that case would be config-if. That means this mode is called as the interface configuration mode. Okay, so do you understand about the two different modes? One of them is global configuration mode, and the other one is interface configuration mode. Do you get that now? Okay. Okay, so let's move on. So the first command that we are going to learn with regards to configuring the switch is, we'll talk about how to configure a name for the switch. So to configure a name for the switch, we have to first enter into the global configuration mode of the switch. Okay, so let me get on into the packet tracer machine and show that to you. Okay, so I'm on the console connection. So first thing that we are supposed to do is get on into the global configuration mode. So to get on into the global configuration mode, the first step would be to get into the privilege mode. Okay, so let's get on into the privilege mode. So to get on into the privilege mode, the command is enable. Okay, so I type enable and press enter. So I'm now into the privilege mode. Once I'm into the privilege mode, I now need to get into the global configuration mode. So for that, I need to type configure terminal. Okay, so that will take me into the global configuration mode. Once I'm into the global configuration mode, okay, To set up the name for the switch, the command is host name. That's the command. Okay, so you need to type in host name and then you're supposed to give it a name. Okay, so let's say for this example, the host name that I want to give is switch1 or SW1. Okay, so the moment I type the name and press enter, you notice that the name of the switch has taken effect. You understand that? Clear about that? So to set up the host name of the switch, you have to get into the global configuration mode and type in host name and then whatever name you want to give to it. Clear about that? Okay, yeah, okay, so let me just repeat that one more time. Okay, so I'll type exit just to come out of the mode. Okay, just give me a moment. Okay, so when it comes to configuring the host name, the first step is, okay, you have to get into the privilege exec mode. So for that, let me first type disable again. Okay, so I'm into the user mode first of all, right? Okay, so in the user mode, I need to type in enable. The enable command will take me into the privilege mode. In the privilege mode, I'm supposed to type configure terminal. This command is going to take me into the global configuration mode. Okay, so once I'm into the global configuration mode, then I'm supposed to type host name and then whatever name I want to give. So let's say the name that I want to give is SW1, and if I press enter, so this is how I configure the host name. Did you get that now? Okay, so it's quite simple. Okay, so that is this part of configuring the host name for a device. Okay, so you have to get into the global configuration mode and then you have to set up a name. Okay, the next thing that we are going to talk about is how to configure an IP address for the switch. Okay, now at this point, okay, we have not learned about IP address at all. We are going to learn about IP address in the next module. Okay, but we are supposed to understand about configuration of an IP address or the command related to putting up an IP address for the switch. Now, what is the purpose of putting up an IP address for the switch? Well, the purpose of putting up an IP address on the switch is to connect to the switch remotely. Okay, so if I want to connect to the switch remotely, that is via the LAN or via the internet, if I want to connect to the switch remotely, I need to have an IP address on the switch. Okay, so that's why I need to go ahead and configure a switch IP address. Okay, do you understand that? We'll be talking more about IP address in the next module, but for now, just understand this. If I want to connect to the switch remotely via a LAN, that is a local area network, or across from the internet, that's where I need to put up an IP address, because you know the switch is going to communicate across the LAN or over the internet using IP address. Do you understand that? Okay, so right now just understand the command and we'll talk more about IP addressing in the next module. Okay, so now when it comes to configuring an IP address on the switch, okay, again for that you're supposed to type in or get into the global configuration mode of the switch, and then you're supposed to type interface VLAN 1. Okay, again let me repeat. Okay, when it comes to configuring an IP address for the switch, okay, so you are supposed to get into the global configuration mode. Now I'm not going to show you the steps again and again to get into the global config mode, because then I'll be just busy wasting time. Okay, so to avoid that, okay, I'm already assuming that I'm in the global config mode, and that's where I am. Okay, so I'm on the switch and I'm in the global configuration mode, and then in the global configuration mode, the command that I'm supposed to use is interface VLAN 1. Okay, now this interface VLAN 1 is called as the management interface. Remember that. Okay, so whenever we talk about a switch, interface VLAN 1 is called as the management interface. So I need to type in interface VLAN 1 and then I need to press enter. The moment I press enter, I find that the mode of the switch now has changed. It has now become config-if, that is config-interface. That is, I have entered into the interface configuration mode. Do you understand that? I have entered into the interface configuration mode, and once I have entered into the interface configuration mode, I have to type in. Okay, are you following me until this point? Okay, so let me know, okay, if you're stuck somewhere, but this is the step that you need to follow. First step, getting into the global config, getting into interface VLAN 1, the mode will change, and then you're supposed to type IP address. Okay, so you're supposed to type in the command IP address, and then you're supposed to put up an IP address. Now, like I told you before, we have not learnt about IP address. Okay, that's the reason, you know, I'll not talk much about IP address at all. I'll directly put up a value. Okay, so whenever we define an IP address, I'm supposed to define two parameters. One is IP address and the other one is subnet mask. Now we are going to talk about what is an IP address, what is a subnet mask in the next topic. So for now, blindly take down the value. So to put up the IP address, the command is IP address and then the appropriate values. Okay, so first value is the IP address itself. Let's say the IP address is 1.1.1.1, and then I'm supposed to put up the subnet mask. Okay, so let's say the subnet mask is 255.255.255.0. Okay, so this is the way you're supposed to do it. You're supposed to put up IP address, then the actual value of the IP address, and then you're supposed to put up the subnet mask. Okay, so that's the command line syntax that you have to follow, and then after that you're supposed to put up no shutdown. Okay, the no shutdown command is going to enable this interface. The no shutdown command is going to enable the interface. You understand that? Okay, so first step is you need to type in interface VLAN 1, then you're supposed to type in IP address and then the IP address value, and then you're supposed to put up the subnet mask, and then you're supposed to type in no shutdown. Okay, so the no shutdown command is going to enable the interface. So that's the reason you find interface VLAN 1 change state to up. So bottom line is it has now come up, or it has now enabled itself. Understood this part? Okay, now once I've done that, I'll just type exit and exit again. So now I'm into the privilege mode. Okay, so you have to just type exit and exit to come out of the mode. You understand that? So that is what you're supposed to put up. You need to type in interface VLAN 1, IP address, the IP address value and the subnet mask, and then you're supposed to put up no shutdown. Okay, so that is how you configure a switch IP address. You understand that? The next command that I'm going to talk about is, okay, how to put up a default gateway. Okay, again, what is a default gateway? We are going to learn about the default gateway concept in our next topic, but for now just understand this. A default gateway is the IP address of a router. Okay, so what is a default gateway? Default gateway is the IP address of a router. Okay, now in our previous session when I was talking about a router as a device, I was telling you a router is used to connect multiple IP networks, right? And a switch was used to connect different devices. Let me repeat that again. A router is used to connect multiple IP networks, and then a switch is used to connect different devices. Okay, so bottom line is if this switch as a device wants to connect with or communicate with other IP networks on the other side of the router, we need to have this IP address configured on this switch as a default gateway, so that it will send the traffic or send the information across to the router. Okay, so that's the purpose of default gateway, but I'll explain it more when we get to the next topic. Okay, but then we need to also configure a default gateway. So how do we configure a default gateway? To configure the default gateway, we need to get into the global configuration mode by typing in configure terminal. Okay, so once I've done that, I need to type in IP default gateway, and then I'm supposed to type in the IP address. I didn't get your question. Can you repeat your question again? Okay, okay, yeah. So you need to get into the global configuration mode, and then you need to type in IP default gateway and then the IP address of the router. Okay, so let's say for our example, the IP address of the router is 1.1.1.10. Okay, I'm just taking an example. Okay, because we have not learned about IP address at all, so it won't make sense for you to understand what 1.1.1.10 may be at this point. Okay, we'll be learning about IP address in the next topic, but the whole idea of this particular slide or the whole idea of this particular topic is to understand how to configure a default gateway. So to configure a default gateway, the command is you have to get into the global configuration mode and type in IP default gateway, and then you define the default gateway IP address. You understand that? Okay, so that's the command that you're supposed to put up. Okay, and then exit. Done. Okay, so this is how you configure default gateway. Okay, so you need to get into the global configuration mode and then type IP default gateway and then whatever value it might be. You understand that? Okay, so this is how you configure an IP default gateway. Now, the next command is to save the configuration. Now, yesterday we had learned about the command to save the configuration. So to save the configuration, the command is copy. Now remember, you have to run the copy command in the privilege exec mode. So copy running config space startup config. Okay, so that's the command that you're supposed to execute. Copy running config space startup config. Now you see multiple lines there. That's because I was pressing tab. I was just typing the initial 2 or 3 letters and pressing tab. That's the reason it was expanding it, and that's why you find multiple lines. Okay, so do not run the command thrice. Okay, in fact, in my previous classes, this has occurred. Like when they see 3 lines, they copy down all the 3 lines, assuming that they are 3 different commands. But then for saving the configuration, the 3rd line is what is the command. That is copy space running config space startup config. Okay, that's the command. So when I press enter, it's asking for the destination file name. It has to be startup config, and I'll press enter again. There you go. It says building configuration and okay. This is how I can save the configuration. Do you understand that? This is how I can save the configuration. So understood how to save the configuration on a switch? Okay, so at this point we have learnt about how to configure a name for the switch. We have learnt about how to configure an IP address for the switch, and then we have also learnt about how to configure a default gateway, and then the 4th command that we learnt about is to save the configuration on the switch. Okay, so is everything clear until now? Okay, so let's get on to the next portion. Okay, now let's talk about certain show commands to verify the configuration. Okay, to check the status of the switch or to verify the configuration that we've done. Okay, there are some show commands that are available. Let's talk about all of those. The first command that we are going to learn about, the show command, is the show version command. Okay, show version. Okay, now let's talk about the show version. So when I go into my laptop, and if I type show version, now remember the show command also has to be run in the privilege mode. So show version, when I do that and when I press enter, there you go. When I type show version, what does it show me? It tells me about what iOS software version am I running on the device. Okay, so the show version command tells me about the software version that I am running, iOS software version that I am running on the device. Like that is, since we are running it on the switch, it's telling me about the iOS software version running on the switch, and it also tells me about the port numbers and so on. You understand? So the show version tells me about the hardware and the software components of the switch. Do you understand the show version command? Okay. The next command that we are going to talk about is show running config. Okay. Now based on the session yesterday, what is the show running config showing you? I mean, is it showing you the configuration from the RAM, or is it showing you the configuration from the NVRAM? We had covered this yesterday, so that's why I am putting up this question here. Okay. So the show running config, does it show you the configuration from the RAM, or does it show you the configuration from the NVRAM? Yes, that's absolutely correct. It shows you the configuration from the RAM. Okay, so that's what is show running config. So let's go ahead and do that. So when I go into the machine right now, and if I type show running config, and if I press enter, okay, as you notice, the hostname command that we had put is visible out here, hostname and SW1. Apart from that, when I press spacebar and scroll down, okay, what you'll also notice is it's showing me interface VLAN 1, and it's also showing me the IP address and the subnet mask, plus it's also showing me the default gateway command that we had put up. Okay, so bottom line is it's showing me the entire configuration that we had done on the switch. You understand? But remember, this configuration that is showing me is the configuration in the RAM. Okay, what is the command to look at the configuration in the NVRAM? We had covered this in the previous session. So what is the command? I guess there's something wrong with your keyboard. I think you have jumbled up the responses. Can you type that again? That's correct. Absolutely right. Show startup config. Show startup config is going to show you the configuration in the NVRAM. Okay, so show startup config, and when I press enter, so again as you see, it's showing me the content of the configuration in the NVRAM. Okay, so do you understand that? Okay, so we covered show version, show running config, and show startup config. The next command that we talk about is the show interfaces. The show interfaces will tell me the statistics and the status of each and every interface. Okay, so show interfaces, and if I press enter, there you go. It starts off with fast Ethernet 0/1. As you see here, it's going to give me the statistics of each and every interface that it has. So it starts off with each and every one, and it's saying that it's disabled right now because I have not connected anything into the switch ports right now. Okay, so for each and every port, it's going to give me similar kind of a thing. See, F0/2 is down, line protocol is down, disabled. Okay, if I scroll forward, okay, so it's going to give me a long output. This that it's going to show me all the 24 or in fact 26 ports, plus it's also going to show me VLAN 1. Do you remember interface VLAN 1 where we had put up the IP address? So there you go. It says VLAN 1 is up, but it's saying line protocol is down. What does this line protocol is down mean? Line protocol is down means there is no cable attached to it, or there is no computer attached to the VLAN 1 interface. Like if I go back to my switch, the only cable that we have attached is the console cable. That is nothing to do with the network, right? So it's not going to communicate based on IP address. It's communicating based on serial connection. So if I connect another PC via the interface, like via the port or via Ethernet, that's when it will show that the line protocol is up. You understand that? Okay. Okay. So do you understand that? So it's saying VLAN 1 is up because we had enabled or we had put no shutdown. Okay. So since we put no shutdown, that's why it's showing VLAN 1 is up, but the line protocol is down because we have not connected any cable into it. Okay. So these are some show commands to check on the switch status. Okay. So there you go. It's showing you the output of each and every command. Show version is what we are talking about here. Then we have the show interfaces, or we can type show interfaces and the interface ID. When you do that, it will give you information specific to that interface. Like in this case, it's giving you information specific to fast Ethernet 0/2. Okay. Then you also have another command that is show MAC address table. The show MAC address table is going to give you information with regards to layer 2 or the data link layer. Do you remember the data link layer which we talked about with regards to the OSI model? Okay, so it's giving you that kind of information, the show MAC address table. Now in our switch, okay, when I go into the switch right now, and if I type show MAC address table, okay, so when I type show MAC address table and when I press enter, it's empty. Why? Because we have not connected any other device, right? Because the switch is supposed to connect multiple devices together, but since we have not connected any other device to the switch, that's the reason this table is empty. And we'll talk more about this when we talk about it in detail in another chapter or in another topic. But that's the main thing about it. Okay, so at this point, since we have not connected any device out here, that's the reason the MAC address table is empty. But this is the one, or this is the table which will give you information about MAC addresses. What is a MAC address? That is nothing but data link layer information. Okay, for now that's the only thing that I'm talking about. We'll talk about this more when we get into another detailed topic. You understand that? Okay. So that was this section talking about some basic commands related to the switch. Okay, so do you have any questions with regards to all the commands that we covered until now? Okay, great. Okay, so let's continue now. The next portion of the topic that we are going to cover is about understanding Ethernet. Okay, so we are going to now talk about Ethernet in general, and then we are going to talk about switch operation. Okay, so we are going to understand Ethernet, and then we are also going to talk about how a switch operates. Okay, so we are going to have a look at both of these parts now. Okay, so to do that, let's first talk about Ethernet LAN connection media. Okay, like in our previous session we talked about LAN. LAN was nothing but local area network, which is nothing but a network which is limited to a geographical location. That is what I told you about a LAN. But how do we create that LAN? We create that LAN using cables, network cables, right? That's how the devices are connected to each other. So when we talk about cables, there are different types of cables that you can have. Like as you can see in the slide right now, I have put up images of the different types of cables. Okay, so when I talk about an Ethernet LAN connection media, there are different types of Ethernet LAN connection media. You can have coaxial cable. Okay, like in India for cable TV connection, we typically find the coaxial cable being used. Okay, but practically if you look at it, for networks, the coaxial cable is no longer used nowadays. Okay, for network connections, the coaxial cable is no longer used, but it was used earlier. You understand? Okay, so coaxial cable is one form of for cable that we can make use of. Another cable that we can have is copper cable. Okay, and nowadays copper cable is what you would typically find for LAN connection media. Like if I want to connect a computer to a switch, I make use of a copper wire. Okay, so we'll talk more about this copper wire as we go along, but that's the main thing that we need to make it of. Another kind of a cable that we need to talk about is fiber optic. Okay, and that is what this cable is about. This is how the fiber optic cable will look like. In fact, if I want to explain about fiber optic, you might have seen, like, there are a lot of decorative items that you get, the decorative show pieces which you get, which throws light, like mini fibers is what you see, and through those mini fibers you see light coming out. That cable is nothing but the fiber optic cable. Okay, so that's another kind of a cable that you can have. You understand that? Okay. So Ethernet, initially when we talked about it, it was based on coaxial. Okay, but like I told you earlier, coaxial is an older technique, but nowadays you will find copper wire or fiber optic. That is what is predominantly used nowadays. Okay, so copper and fiber optic is what is used in a LAN connection media. Okay, so going along, when we talk about the LAN connection media further, okay, so this is how a copper wire would typically look like. Now, of course, this cable is just showing you the wires, okay, but it will have a connector plugged in or connected to it. We'll talk about this more, but then talking about it, the Ethernet cable which you see out here, the wires within that Ethernet cable is all twisted. Do you see that? Okay, the wires within this cable out here is all twisted. That's the reason this kind of a cable, or this kind of a copper cable, is also called as unshielded twisted pair. Okay, let me just write it down for you. Okay, so this kind of a copper cable that you see out here is called as unshielded. I'll just change the color because it's not visible. Okay, so let's say I put it up in red. So unshielded twisted pair. Okay, so that is what this kind of a cable is called as. Okay, or in short, it's also called as UTP. Okay, so unshielded twisted pair or UTP, that is what it's called as. You understand? Okay, so that is what it's called as unshielded twisted pair or UTP. So when I talk about this UTP based Ethernet, which uses copper inside it, okay, that is what is widely used. Okay, and the standard that it follows is 10 base T. What do I mean by 10 base T? 10 base T means the basic speed that this kind of a cable can provide you with is 10 Mbps or 10 megabits per second, and that's why this kind of a cable is called as Ethernet cable. Okay, so when I talk about this unshielded twisted pair, it started off with 10 Mbps. Okay, so 10 Mbps is nothing but 10 megabits per second. Then you had 100 Mbps, that is fast Ethernet. Okay, and nowadays the UTP cable can also provide you speeds of up to 1 Gbps, that is 1 gigabit per second, or in fact it can go further ahead and give you speeds of up to 10 Gbps also. You understand? So these are the various speeds that the UTP cable can provide you with. You understand? Now, why is it called unshielded twisted pair? Okay. Now, one of the reasons I told you, the wires inside this particular cable are all twisted. That's why it's called as twisted pair. But why is it called unshielded? It's called unshielded because you don't find any other kind of a shielding inside it. The only thing that you have is you have this insulator, which is nothing but plastic or PVC. Okay, and inside this PVC you will have all these wires which are twisted with each other. That's why it's called unshielded. There is no other shielding inside it. Okay, so that is what is typically used with regards to copper wire. Okay, but then, okay, another kind of a cable that you can have is fiber optic cable. Okay, now before I get on into fiber optic cable, when I talk about this UTP cable, the longest cable that you can have, or a single cable which you can use, can run up to 180 meters. Okay, so a single copper wire can run up to a length of 180 meters. Okay, so you cannot run a cable beyond this. Okay, now why am I talking about that way? Okay, you can have a cable longer than 180 meters, but the problem with that is, okay, if you have a cable longer than 180 meters, the performance or the quality of the data transfer is reduced. Okay, it becomes unreliable. Okay, the information that you're going to pass through this wire may or may not reach the destination, so it becomes unreliable. That's the reason the reliable distance that it can go up to is 180 meters. Do you understand that? That's the limitation of the unshielded twisted pair. Do you understand that? Okay, but now let's talk about the other kind of a cable that we can have, that is fiber optic. When I talk about fiber optic, this is the fiber optic cable that you see here. Okay, so this cable that you see here is nothing but the fiber optic cable. Now, when I talk about fiber optic cable, it can go up to 10, 20, 30, 40, or it can go to a huge distance. The fiber optic cable can run through a huge distance. It does not have the limitation like copper wire. It can go beyond that. Why? Because in a fiber optic cable, okay, it's not using copper. Instead, it's using fiberglass or glass in general, and through the glass, it's passing light. Okay, whereas when I talk about the copper wire, it's using electrical signals through it. Whereas in the case of fiber optic, it's passing light through it. That's why it can travel larger distances. You understand? That's the advantage of using fiber optic as compared to copper. Okay, that's the reason you find nowadays for broadband connection everywhere you find copper instead of copper cable they lay down fiber optic, and from the fiber optic they give you Ethernet connection or the copper wire. Okay, so that's the kind of broadband that you find nowadays, right? That's because fiber optic can run long distances. Do you understand that? Clear about that? Okay. Now, talking about the unshielded twisted pair or the UTP cable, okay, so this cable has to be crimped using an RJ45 connector. That's what you need to have. These wires need to be terminated into an RJ45 connector. Okay, so typically they can give you speeds from 10 Mbps to 10 Gbps. Okay, and the cable that we typically use, the UTP cable that we typically use, can also be called as, okay, they are given another name also. They can be called as Cat 5E or Cat 6. Okay, now what do I mean by Cat 5E or Cat 6? Cat is nothing but category. Okay, so you can have category 5E cable or you can have Cat 6 or category 6 cable. Now, what is the significance of these cables? Depending upon the category 5 or category 5E or Cat 6, okay, the speed of the cable would vary. Okay, so Cat 6 can give you speeds of up to 10 gigabits per second. Okay, that is what it means. So the advantage of using these UTP cables is it is less expensive. Okay, the media or the connector size is small, and the maximum cable length would vary depending upon the various kinds of category cables that you can make it of. Okay, but the maximum it can go up to is 180 meters. Do you understand that? So that's the main thing about UTP cables. Do you understand that? Okay. Okay, so that's the kind of connector that you can make it of for copper cables. Okay, so the cables are crimped or connected with these kind of RJ45 connectors, and for connecting this RJ45 connector to the cable, okay, you need to make use of a crimper. Okay, now let me show you an image of a crimper. So I'm just going to search for RJ45 crimping tool. Okay, that's what I'm going to search for. When I do that, okay, let me open up this one. Okay, and when I click on this further, okay, so that's how an RJ45 crimping tool will look like. Okay, this is where you have the various kind of connectors. Now, this crimping tool which you see here has or supports various RJ connectors like RJ45, which is used for Ethernet or LAN cable, RJ11 or RJ12. These two are used for telephone cables. Okay, so that's the reason you find three different slots here. The middle one is for Ethernet, whereas the other two slots are the RJ11 and the RJ12, which is used for telephone. And this thing which you see here, this is a cable cutter. You know, to cut a cable, this is what is typically used. You understand that? Okay, so you have this crimper tool, and then you have this kind of a cable cutter. Okay, and using these tools, you would connect this connector with the cable. Okay, so this connector is called as the RJ45 connector. Now, what is this RJ? RJ means that is radio jack. Okay, RJ means radio jack. Okay, let me just type it down out here. RJ means radio jack. You understand that? Okay, so it is RJ or radio jack 45 connector. That's the kind of connector that you have. And then this is the connector that goes into the cable. But ultimately you need to plug into somewhere, right? Into the switch or into a wall socket, because typically or in a practical environment, the switch would be placed in the server room. Okay, the switch as a device would be placed into the server room. Now, what is a server room? It is a room which would be filled with all your networking equipment like switches, routers, server devices and all that. Okay, and it would be like having heavy cooling inside it. Okay, so all your switches and everything would be in the server room. But when I talk about your computers like your laptop or your desktop, they would be at the individual user spaces or the user tables, right? Okay, and these tables would be at the individual workspaces. Like if you visit offices, people are working at different locations. So from that particular location to the server room, there has to be a cable that needs to run through. Okay, so typically your laptop or your desktop would be connected to a wall socket. So that wall socket is nothing but the jack. Okay, this is how that wall socket would look like. Okay, this is the front portion that you would see, but behind that you would have the cable connected to these connectors out here. You understand that? Okay, and this is where you will plug in this RJ45 connector, or in turn you would connect in the cable. So one end of the cable will go into this wall jack, and the other end of the cable will go into your desktop or into your laptop. Do you understand that? Clear about that? Okay, so that is how you would connect it. And then from this wall jack, okay, the again the UTP cable would be connected out here, and another end of that cable will go into the switch. Okay, so that is how you would have it. Okay. Now talking about fiber optic or optical fiber. Okay, optical fiber has different modes inside it. You have the single mode optical fiber, wherein these are the various kind of layers which you would find inside it. Okay, you have the core diameter, which is somewhere around 8 to 12 micrometer. Okay, micrometer is like 10 raised to minus 6 meters. Okay, it is very small in size or thin. Then you have the cladding. Cladding is nothing but a plastic kind of a coating that it has, which is again 125 micrometer, and then you have the outer coating of the cable, okay, which is again 250 micrometer. Okay, so that's the composition of a single mode fiber. Okay, that is how you would find a single fiber cable available, or single mode fiber available. Okay, another kind of an optical fiber that you would have is multi-mode. Okay, so typically they are classified into step index fiber, then you have graded index fiber, and then you have single mode fiber. Okay, but in all of the cases, what is the difference? The difference between all of these are the thickness or the width of the cable. Okay, so as you see out here, internally it is 200 micrometer and externally it is 380 micrometer. When I talk about graded index fiber, internally it is 50 to 100 and externally it is 125, and when it comes to single mode, internally it is -10 or very small, and externally it is 125 micrometer. Okay, but another major difference between all these different fiber types is the way in which the light is going to pass through. These red lines which you see out here, is the way in which the light is going to pass through. In the case of step index fiber, the light is going to pass through in a zigzag fashion. When I talk about graded index, it's going to pass in this kind of an ellipsoid fashion, and when I talk about single mode fiber, it's going to pass in a straight line. Okay, so that is just giving you some basic idea about fiber types. Okay, but then typically this is what you would have. You understand? Now, getting along, these are the various kind of fiber connectors which you would have. Okay, now it will all depend upon what kind of a socket that you have with regards to your device, but depending on that, you have these different types of connectors available out there. Now, with regards to the exam, you're not supposed to know about specifications of each and every connector, but for general knowledge, if I talk about it, I know this slide would be important. Okay, so you can get hold of more information on the internet, but these are the different types of connectors that are available, and there are a lot of different types of connectors. But when I talk about copper wire, there is only one type of connector, that is RJ45. But when I talk about fiber optic, there are a lot of variations to it. Okay. Now, talking about Ethernet in general, okay, the information that is passed or the data that is passed. Okay, so the Ethernet frame. Do you remember which layer do we find the frame? According to our previous sessions, when we talked about the OSL model and everything, we talked about on a particular layer we have the frame. Do you know which layer has the frame? Which layer passes the frame? Well, you are partially right. It's not link, it is data link. Yes, that's right. Okay, so it is data link layer. That is layer 2, which is going to pass the frame. And Ethernet, when we talk about it, okay, it is part of layer 2. Okay, so let's talk about how this Ethernet frame looks like, or what is the kind of information that is going to store. Okay, now before I get on into understanding or talking about the frame, okay, we need to talk about some sizes. When we talked about bits and bytes and all that, let's talk about all of that. Okay, so information, when I talk about it, or data when we talk about it, okay, data or information typically is transmitted in the form of bits or bytes. Okay, so when I talk about bits means it can be either 0 or it can be 1. That is what is bits. Okay, a single bit can be 0 or 1. Okay, so saying that I have, okay, let me just write it down for you. So I have bit, okay, that is nothing but 0 or 1, and then I have byte. Byte, when I talk about it, it's nothing but 8 bits. Okay, that's a conversion. So 8 bits become 1 byte. Okay, so sorry about that. So 1 bit is either 0 or 1, and 1 byte, when I talk about it, it is 8 bits. Do you understand? Okay. Similarly, we need to talk about 1 nibble. 1 nibble, when I talk about it, it is nothing but 4 bits. Okay, 1 nibble is equal to 4 bits. Okay, so that is some background information that you needed to have with regards to the sizes. Okay, so whenever I talk about Ethernet frame, the Ethernet frame will have the various fields inside its info. Okay, now how will a frame look like? The frame will have the raw data, the actual data that needs to be transmitted, plus it will have all the headers. If you remember, we talked about data encapsulation earlier, right? So wherein it will have a lot of headers in it. So that header will have a lot of fields inside it. Like if you see this particular frame here, okay, this is your actual data. Okay, let me just stop the drawing out here. Yeah, so this is your actual data that you want to transmit, but that is your header. This portion that you see here, it is the header, and this portion that you see here is the frame check sequence. that is the trailer. Okay, so when I talk about the header and the trailer, they have some specific sizes to it, and all the sizes that you see out here, these numbers 8, 6, 6 to 46 to 1500 and 4, all these are nothing but the sizes in bytes. Okay, so this preamble which you see here, that's the first field, that is 8 bytes. Then we have destination address. Destination address is nothing but the address of the destination where the frame has to be sent out to. Okay, so that is again 6 bytes. Okay, 6 bytes means 6 multiplied by 8, that becomes 48 bits. Do you understand that? Okay, so that is what is this destination address. Then it will also contain the source address from where this frame is being sent. Okay, so that is again 6 bytes. Then we have the type of Ethernet frame, that is 2 bytes. Then the data itself, which can range between 46 to 1500 bytes, and then we have frame check sequence, which is another 4 bytes. Do you get that? That's the kind of info that is going to store, or that's what is going to carry inside it. Clear about that now? Okay, now saying that Ethernet, when I talk about it, okay, it falls under this particular standard of 802.3. Okay, so when I talk about this 802.3 standard, okay, that's how the header is defined for the 802.3 standard. The same fields like before, okay, but here you also have one more field out here, which is a 1 byte, that is nothing but SOF. SOF is nothing but start of frame delimiter, which indicates that it's a start of frame for the Ethernet. Okay, apart from that, instead of the type field, it will have the length field, which is of 2 bytes, sorry, and then it will have the 802.2 header and the data. Okay, so that is according to this particular IEEE standard, but an actual Ethernet frame will look something like this one. Okay, so that is how an actual Ethernet header will look like. Are we clear about that? Understood about this portion here? Where can we find the structure? I didn't get your question. Can you repeat your question again? Oh, okay. See, the bottom line is, like, do you remember data encapsulation? Let me ask you this question. That will give you a clear picture of what I'm talking about. Do you remember data encapsulation? Yeah. So what is happening in data encapsulation? You had your actual data that you wanted to send, but as it was passing through the various layers, there were various headers added to it, right? Okay. So when we are talking about data that is passing through the various cables or the media, it is going to pass in bits or bytes. Okay, that is what is going to happen. But you know, for us to read the information, okay, the actual information that is being processed by the computer is in this format. Okay, so typically with regards to switches work on layer 2, right? That's where you would find these frames or this kind of a structure. Okay, so if you look at the data that is coming out of a switch or the data that is entering into a switch, it will look out or it will look like this one. Do you understand that? Okay, so typically a frame will look like this one. Okay, so of course if you look at the data or information that is passing through the wire, it will all be zeros and ones. Okay, you will not be able to understand anything out of it. But when I talk about these devices like the router or the switch, like here we are talking about frame, right? So in that case we are talking about layer 2 device like the switch. So switch is going to learn the information in this manner. Okay, it's going to look at the header value, the data and the trailer value. Okay, that's how it's going to understand. Yes, typically it's only for layer 2 devices. It would be incorrect to talk about only about the switch. All layer 2 devices are going to make use of frame. Do you understand that? Okay, so like in the future as we go along in this particular course, We are also going to talk about other layer 2 devices like frame relay switch, then we have MPLS switch and all of that. So all of those are going to pass frame. So all of those devices are going to understand frames in this format, or they are going to understand the frame structure in this particular format. Do you get that now? Okay. So let's talk about now the communication within a LAN. Okay. So when I talk about communication within a LAN, okay, there are three major types of communication available. We have unicast, that is one-to-one communication. Unicast is one-to-one communication, that is this computer and this computer communicating. Like, let me just highlight it for you. Okay, this computer and this computer communicating. So if these two are communicating with each other, that is called as unicast. You understand? Okay, so one-to-one communication is called as unicast. The other kind of communication that we can have is broadcast. Broadcast means one to all. Okay, so let me just write it down for you so that it becomes easier. So as I was talking before, unicast is one to one. Okay, so the one-to-one communication is called as unicast. But when I talk about broadcast, broadcast is one to all. All means each and every one. Okay, so as you notice here, this computer is sending some info, but that is being received by all the other computers in the LAN. That is called as one to all. You understand? And then we have the third kind of communication called as multicast. Now what is multicast? Multicast means one to a group. Okay, so what is multicast? One to a group. That is what is called as multicast. Okay, now what do I mean by that? Okay, one to a group is like, this computer is sending some info, but that is being received by only these two computers. Why? Because these two computers belong to a client group. Okay, so if I'm sending out some information to a group, that's what is called as multicast. Okay, so let's talk about it this way. Like when I talk about this online meeting, okay, when I talk about this online meeting, okay, when I say something or when I'm sharing something, it's going to all the people who are participating in this group or in this online session. Okay, it is not going to everyone. It's only going to all the people who are participating in this particular group or in this particular session. That is what is called as multicast. Do you understand that now? Understood multicast? Okay, but if I talk about unicast, unicast is like one-to-one communication. Let's say I'm just talking to one single person. Nobody else can receive that particular communication. I am only talking to one person, and only that person can receive or hear what I'm saying. That is what is called as unicast. Okay. Okay. Whereas broadcast, when I talk about it, it is like one to everyone, all of them. Okay, where it is something similar to like if you are working on Facebook, if I put up a public post. Okay, what happens when I put up a public post? Everyone who is either on Facebook or who is not even on Facebook can see that data, right? When I post something on Facebook publicly, everyone can see it. Yes, that's exactly what is broadcast. Do you understand that? Okay, so that's the example of it. A public post on Facebook is like broadcast. Okay, but if I'm posting something only to my friends, which means I'm sending it only for a group, right? That is what is multicast. But if I'm sending out a private message to a single user, that is unicast, one-to-one. Do you understand that? Understood the three different types of communication? Okay, okay, great. Okay. Okay, now we also have some other things that we need to talk about like MAC address and all that, but that we'll be talking about it in our next session. Okay, so we'll be talking about the remaining component of this particular topic, that is MAC address components and so on, in our next session. You understand that? Okay, clear about that? Okay, so do you have any questions of what we covered or the topic that we covered today? Now remember to practice on the commands that we covered today, because I'll be giving you some labs towards the end of the topic, which you are supposed to do it on your own. Okay, so there you should not be stuck with regards to what command do I use and all that. Do you get that? And also, if possible, try to run packet tracer on your own based on the demonstration that I gave you today, and try to work on the interface of what things are, how to add a device and all that, so that it becomes easier for you to understand how to work on packet tracer. Okay. And if you have any questions, you can come up with your questions in the next session, and we'll definitely discuss about that. Okay. So let me go ahead and stop the recording now,